Okay, so welcome back. Now we're going to start doing some examples involving the other trigonometric functions. Okay, so before we get started, I want to recommend to you that you study and you work with as many trig functions as you can, and memorize. Go back if you need to memorize the identities and things like that. But as things get more complicated, the trig identities are going to be your lifeline. Okay, the more you understand, the more you know about the trig identities, the more complicated ones, the more you memorize those, you will find that taking derivatives of other types of with trig functions or more complicated expressions involving trig functions is going to become easier. Okay, but and later on when we get to integrals, doing integrals of trig functions are going to, if you learn the derivatives now, integrals will become easier when you deal with trig functions. A website that I will recommend that you go check out is called Black Pen Red Pen. He does a great job with dealing with integrals, which we'll cover towards the end of the semester, but when you go to Calc 2 and Calc 3, you're going to do integrals all over the place. Okay, so just some advice. Okay, so the first example here is they want us to find the equation of a tangent line for this function at x equal to pi over 4. So we're looking at an angle, right? So what's the point that we're interested in? So it's going to be pi over 4, comma, well, what's the cotangent of pi over 4? It's 1. So this is the point we're interested in. So we want to know what the equation of the tangent line that goes through this point on this function. So now we need to find the slope function, right? Because we need to know the slope of the tangent line. So f prime of x, the derivative of cotangent is negative, negative cosecant squared x. Okay, now we need to know the slope at pi over 4. So we want to know pi over 4. Well, this is equal to what? What's cosecant? Cosecant is 1 over sine. Okay, so this is going to be negative 1 over sine squared pi over 4. Well, what's the sine of pi over 4? The square root of 2 over 2. Okay? Or 1 over the square root of 2. Okay, so let's put it that way because that'll be easier. So negative 1 over, what's this? This is going to be 1 over the square root of 2, right? Now normally we'd rationalize this and say square root of 2 over 2, but I notice this is going to be 1 over and we're squaring it. So we don't really have to rationalize it because it's going to undo itself. So this is going to be negative, squared. And so this is just going to become 1/2. So then this is going to be negative 2. So the slope is negative 2. Okay, now we're ready to find, with our point and the slope, let's find the y-intercept. So y equals mx plus b, which then gives us 1 equals negative 2x. What's x? Got to plug in for x. It's negative 2 times pi over 4. Okay. And so what do we get? We get b is equal to what? 1 plus pi over 2. And so now we're done. So the equation of the tangent line is going to be y equals negative 2x plus 1 plus pi over 2. And I believe that's the correct answer, yeah. Okay, now let's do the next one. Now the next one just wants us to find the derivative of this function. Okay, so f prime of x equals, so again, because these are continuous, because these are differentiable, okay, these are differentiable functions, we can do it term by term. So f prime of x, the derivative of cosecant is what? That's going to be negative cosecant x cotangent x. Now here we've got a product of two functions, so we're going to have to do the product rule. So we're going to have plus, now we're going to do the first times the derivative of the second, which is secant squared x, plus the derivative of the first, which is 1, times the second, which is tangent x. And is there any way to simplify this? Let's see here. This is going to be 1 over sine. Yeah, 1 over sine, cosine over sine, plus 1 over cosine squared, tangent. Yeah, I don't think, yeah, there's nothing that we could do to simplify that, so we're just going to leave it that way. Okay, always look for a way to simplify things, but in this case, we can't simplify anything. I was thinking maybe we could use an identity, but nothing pops out. So this is it. That's the answer. And sometimes this is okay. Sometimes it's going to just be something like this. Okay, have a great day.